Alright guys, I'm going to go over the second conjecture example. So some of you have cracked it, that's fine, you proceed with what you're doing. If you haven't done the second conjecture question, the one on page 28, let's follow along. I'm going to make my way through the whole thing. Even if you got up to the later part, it's probably useful to pay attention to the earlier parts, because it'll refresh it in your mind and help you make sense of what's this conjecture we're making. So, consider the function x on x plus 1, where x does not equal minus 1. The graph is shown below. On the graph above, draw the tangent. Okay, so don't miss the mark there. Draw the tangent when x is 1. So, I'm going to provide a, let's say that's my axis, here's the asymptote, here's the function. When x is 1, that's like a line that you're drawing here. Alright, so the tangent's going to look something like that. Alright, so draw the tangent, use your ruler, just draw it as best as you can. Part B, determine f dash of x. So, we've got the function is x on top of x plus 1. In order to find f dash of x, we need to use the quotient rule. We've got u divided by v. U dash v, take away uv dash on top of v squared. Alright, so that's going to simplify, x will cancel. That's part B. Okay, C. Hence show that the equation of the tangent to the curve at the point where x is 1 is x take 4y equals minus 1. So this is presented in general form. I said we need to be competent in the process of finding a tangent in general form. So we're going to use the general form process. You would still get full marks if you did y-intercept and rearrange it. That would be fine. Alright, it's just going to take a bit longer. Let's just go straight to the general form process. So for a tangent, we always need two things. We need the point of contact. Alright, we've got x is 1. That's where we're drawing the tangent. We're drawing the tangent at x is 1. And then we need the y value. That's from the original function. When x is 1, we have 1 on top of 2, half. So we've got x is 1, y is half. That's the point of contact. And then we need the slope. Okay, so we've got the point of contact where the tangent touches. We need the slope of the tangent. That's why we use the derivative function. Notice the hence. Whenever it says hence, it means using what you saw above. Using what you saw above. Hence, find the slope. And so if I put the number x is 1 into the slope function, I'm going to have 1 on top of 1 plus 1 squared. That's 1 on top of 2 squared. That's 1 on top of 4. Our slope is 1 on top of 4. Okay, back to general form. If we have a on b, then ax take by is c. If we have negative a on b, then ax plus by is c. We have positive 1 on 4, which means the equation of the line is 1 lot of x, take 4 lots of y equals c. We determine c by substituting in the point of contact. We've got 1, take 4 times half. We've got c equals minus 1. So therefore, 1 take 4x, excuse me, 1x or x, take 4y equals minus 1. Alright, now these questions are going to be set up in such a way, like a good test and the exam, it's going to be set up in such a way that even if you can't answer part B or part C, you can still answer part D, right? Part D says find the y-intercept of this tangent. So the tangent is, in general form, x take 4y equals minus 1. The y-intercept for all functions, the y-intercept occurs when x is 0. Alright, when x is 0, that's when it crosses the y-axis. Think of a Cartesian plane. Any y-intercept is going to be x is 0. So when x is 0, we have minus 4y equals minus 1, y equals a quarter. The y-intercept is a quarter. Okay, move on to the table. The equation of tangents to the curve at the point x equals 2 and x equals 3 are given below. Use them to complete the table. So you're given the tangents and they want you to fill in the y-intercept. Well, you've already got the first one, don't you? I'm going to draw up the table here. X is 1, x is 2, x is 3. X take 4y is minus 1. We've got x take 9y is minus 4. And x take 16y is minus 9. And the y-intercept. Alright, so we saw the first one, the y-intercept was a quarter. Look at the second one. What's the y-intercept? The y-intercept occurs when x is 0. So that means you'd have minus 9y equals minus 4. If it helps, write it out. Minus 9y equals minus 4. Divide both sides by minus 9. Y is 4 on 9. And then here, minus 16y is minus 9. Divide both sides by minus 16. Y is 9 on 16. Alright, so we've got when x is 1, 1 on 4. When x is 2, 4 on 9. When x is 3, 9 on 16. Hence, make a conjecture about the y-intercept when x is a. Okay, make a conjecture about the y-intercept when x is a. Very difficult to see a relationship between this number and this number. Okay, it's difficult to see. I'm not going to say it yet. All right. So that's what you're getting a mark for a bit of insight there. What's the relationship? If we have A, what's this y-intercept in terms of A? All right, let's say we can't get it, can't see it. Doesn't matter. We can prove it and use our proof to come back and get this mark. So let's, even if we can't see it, let's move on to the next part. All right, I can't see a conjecture. It says prove or disprove the conjecture. Now, it wants to know, let's clear a bit of space. So, function is x on x plus 1, and the derivative was 1 on top of x plus 1 squared. That's all good. We've still got that information. I'm just putting it up there because that's what we got in our first part. It's saying, what is the y-intercept of the tangent to this function when x is 1? Alright? What is the y-intercept when x is a, sorry? What is the y-intercept to this function? What is the y-intercept of the tangent to this function at x is a? So that means we need to find tangent at x is a. We want to know what's the equation of that tangent and get the y-intercept from it. So if you think for a tangent, we need the point of contact. Okay, we're told the x value of the tangent is a. The x value of the tangent is a. The y value is going to be a on top of a plus 1. A on top of a plus 1. That's the y value. Alright, remember with these proofs we're doing it deductively. So we're doing it for all values of x, right? Alright, so we've got the point of contact. Then we need the slope. Well, the slope is just in terms of a as well. If we put the number a where the x is, the slope is going to be 1 on top of a plus 1 squared. Okay, so we've got the slope, we've got the point of contact, we've got everything we need for a tangent. All we're trying to find here is the y-intercept of this tangent. That's why this one's only worth 4 marks, right? We've maybe got 1 mark so far from stating this information. Let's find the equation of the tangent. And here, you could do it in y-intercept form, you could do it in general form. It's not going to make a difference because they're interested in the y-intercept, right? I'm going to proceed with the general form, okay? So our slope is 1 on top of a plus 1 squared, right? It's positive a on top of b. Therefore, 1 lot of x, take take a plus 1 squared lots of y. Yes, that's right. Equals c, all right? Think of the general form I have written up here before. If we have slope a on b, then ax take by equals c. All right, that's what we're getting from general form. If you prefer, do it in y-intercept form. Now, to determine the value of c, we substitute in, when x is a, y is a on top of a plus 1. So I'm going to put that where the x is. A plus 1 squared. And that where the y is. Okay, we'll process this a little bit. Now here I've got a plus 1 at the top and a plus 1 at the bottom. So one of them is going to cancel. So we're left with a times a plus 1 at the top. Alright, so we've got c is negative a squared. Now, remember, because it's general form, c is not the y-intercept, it's a capital C, so it's the constant. And so the equation of this tangent is 1x, take a plus 1 squared y, equals negative a squared. That's the equation of the tangent in general form. Alright, so we found the tangent. Okay, 3 marks so far. We've got 3 marks out of 4. To get the 4th mark, we need to show that the y-intercept of the tangent. The y-intercept occurs when x is 0. That's when this is true, right? When minus a plus 1 squared y equals minus a squared. We want y by itself. We want to know what's the y value. It's going to be minus a squared on minus a plus 1 squared. The negative at the top, bottom, they're going to cancel. That is the y-intercept at x is a. So I did it in general form there, and it actually does turn out it's a little bit more complex doing it in general form, this last part. It's a little bit more complex doing it in general form. But remember, I said let's pretend we can't get the conjecture, all right? We can still prove it. Let's look back here. If our conjecture is that the thing is a on top of a plus a squared on top of a plus 1 squared. Does that work out? Let's check this out. 1 squared on top of 1 plus 1 is 2, and 2 squared is 4. Yep, it works here. What about x is 2? 2 squared is 4, and 2 plus 1 is 3. 3 squared is 9. It works. It satisfies that. So that's what they're looking for the conjecture for you to make. Difficult to see. Alright, and you can spend ages just thinking about it. If you can't see it, move on to the proof. What is it asking me? It wants the tangent at x is a to this curve. How do I do a tangent? I need the point of contact. I need the slope. Yep. Yes, they're not numbers, but the same mathematics applies. Okay, find the tangent. Done. Find the y-intercept of the tangent. Y-intercept when x is 0. So, yeah, that's another conjecture problem. I've got a whole booklet of these that I'll probably bring next lesson. So, yeah, hopefully you're enjoying it. All right, proceed with where you're up to.